Okay, so we're looking at area and perimeter of rectangles now. And we're just going to start by having you just look at this first shape here, this array. Okay, and these should be quite familiar to you because we use these through multiplication for many years. And so I have an array that has 3 rows, right? And 4 columns. Okay, and if we remember how we wrote this as a multiplication sentence, right? So this would be represented as 3 times 4. Okay, now I want you to have a look at this array and compare it to our rectangle there that we would use to find area. And just tell me what you see that's the same, or just say it in your head. Okay, and what multiplication statement would give us the area of this rectangle then? Okay, so if in your mind you said 3 times 4, you are correct, right? Because we have the same, we have 4 columns, right? And we have 3 rows. And if we multiply that together, we would come up with 12. And if we counted these, it'd be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I can say, and if these are centimeters, right, I can say that if I want to find the area of a rectangle, I could multiply the length of that rectangle by the width of that rectangle, just like we do with our array. So this could be 12 centimeters squared. Okay, so we're going to look at this a little bit more. If we're looking at this rectangle, I just want you to pause the video and figure out what the length and width of this rectangle would be. Okay, so I'm hoping what you did is you took the length of this rectangle, 50 centimeters, and you multiplied it by the width of this rectangle, which is 30 centimeters, right? And this is an open array. This is something that you have seen. I know you've seen because we did this in class. Okay, so I have 50 centimeters by 30 centimeters. 5 times 3 is 15, and then I add the zeros, and I add my centimeters, and I add the square to account from the square centimeters that we're using to measure this. Okay, and I'm just going to change this here. I decided to be a little nicer. Okay, so now I'm going to get you to find the area of this rectangle as well. So just pause the video and find the area of this rectangle. Okay, so now coming back, we have a length of 70 meters multiplied by 20 meters, and that 7 times 2 is 14, and I add my zeros in with my meters and squared. Okay, so now how do we come up with a formula for this? Well, I'm hoping that you guys in your mind, okay, have said that I take the length, and I multiply it by the width, okay, or L times W. Okay, and so the length of this shape or this rectangle is 10 centimeters. Multiply, because I'm substituting the length in for that symbol, right? That's taking this spot. And 5 centimeters for width, substituting in for the W, and I multiply them together, and I have 50 centimeters squared. Remembering to put that in there, right? All right, this is going to get a little squishy. So now I'm comparing area and perimeter, and if I count the measurement on the outside, 1, 2, 3, 4. So say I'm going to pretend that this is 4 meters, and 1, 2, 3, 4, 5, 6, and this is 6 meters. So to find the area, okay, I'm going to multiply 4 meters times 6, which is going to equal 24 meters. Okay, now the perimeter is going to equal 4 times 2, which is 8, right? Plus 6 meters times 2, which is 12. And then I'm going to add those together, and it's going to be 20. Oh, I forgot to put the squared. 20 meters. Okay, now I am going to find the area and perimeter of this next shape of B. Oops, it's because I said B. Okay, and perimeter. Okay, now the length times width, right? So 1, 2, 3, 4, 5. That's 5 meters. 1, 2, 3, 4, 5, 6 meters. Okay, so it's 5 times 6, and that's going to equal 30 meters squared. The perimeter, it's 5 meters times 2, which is 10, right? Plus 6 meters times 2, which is 12. And then I'm going to add those together, which is 24 meters. Okay, so let me just write this so that it's easier to see. The area here, whoops, wrong pen. The area here is 24 meters squared, and the perimeter is 20 meters, okay? And this one's just a little easier to see. The area here is 30 meters squared, and the perimeter here equals 24 meters. I'm doing this because we're going to use this. All right, now the next one, C. Okay, the area here is 1, 2, 3, 4, 5, 6. 6 meters times 1, 2, 3, 3 meters. Okay, it's 18 meters squared. The perimeter is 6 meters times 2. Okay, that is 12 plus 3 meters times 2. So I guess you guys are figuring out why I was making you guys write things out in that format. And that's 6. So 12 plus 6 equals 18 meters. So the area for this one equals 18 meters squared, and the perimeter equals 18 meters. Then I'm going to look down here, okay, and I have 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's 9 meters, and this is 1 meter. So the area is equal to 9 meters times 1 meter, right? The length times the width. So that would be 9 meters squared. And the perimeter is equal to the length, 9 meters times 2, because I have 2 sides there, plus, so that's 18, plus 1 meter times 2, so that's 2. So 18 plus 2 is 20 meters. So the area is equal to 9 meters squared, and the perimeter is equal to 20 meters, right? Because it's around the outside. Okay. Next one. I have 1, 2, 3, 4, 5, 6, 7, 8. So that would be 8 meters. I'm just pretending each one is meter. 1, 2, 3. So that would be 3 meters. And so I have the area equals 8 meters times 3 meters, which equals 18 meters squared. And the perimeter is 8 meters times 2, which is 16, and plus 3 meters times 2, which is 6, and 16 plus 6 equals 22 meters. So the area here is equal to 18 meters squared, and the perimeter here is equal to 22 meters. Now, what I want you to do is compare these. So what I'm going to get you to do, get this out of the way, all right, is you are going to look at your work, and you are going to organize these rectangles, you're going to list them, okay, from the least to the greatest perimeter and the least to the greatest area. So the perimeter, you're going to put the smallest number on this side, and it's going to go to the biggest, and the area, you're going to go from smallest to biggest. Okay, pause the video and start that now. Okay, so the perimeter is going to go as followed, okay? So from the least to the greatest is 18. Oh, I'm doing wrong one. I'm doing dee. All right, the perimeter is going to be 18 meters, okay? And we're going from the least, why does it keep doing that? Least to the greatest. So that is C. Then I have A. Okay, so that's C. Then I have A, which is 20 meters. And then I have another 20 meters. So those ones are actually equal to each other. So instead of putting I'm just going to put a little comma there because they're equal to each other. So those two are next. So that's B, okay, is 20 meters. Okay, and then I also have D, which is 20 meters. And then I have E. I'll just get rid of this and put commas. And then I have E, which is 22 meters. Okay, now I'm going to compare the area. So I have, the first one I have is D, which is 9 meters squared. And then I have C, which is 18 meters squared. And then I have A, which is 24 meters squared. And then I have to do E, which is 24 meters squared. And then I have B, oops, this was E. Then I have B, which is 25 meters squared. Okay, are your lists the same? No, right? Does the rectangle with the greatest area also have the greatest perimeter? So which one had the greatest area? E, it does not, or sorry, the greatest area is B. It does not have the same, E had the greatest perimeter. Does the rectangle with the smallest perimeter also have the smallest area? No, right? Are there rectangles with the same area? So if we look here, we have rectangles that have, we have rectangles here that have the same area. Do they have the same perimeter? No. A would be here, A would be here, B is here, and D is here, right? Do we have do we have rectangles that have the same perimeter? Okay, we have these two rectangles here that have the same perimeter. And do they have the same area? No. So what do you do with the length and the width of a rectangle to calculate the area? Just a recap. Okay, we multiply them together. What do you do with the length and width of a rectangle to calculate the perimeter, right? You add them and you multiply them by, you're going to multiply them by 2. Okay, so you can either do that by how I did it here, or you can add the length plus the width and then multiply by 2. So you can make that choice if you want, however you want to do it. So the perimeter and the area are related to each other, but they don't depend on each other.